In this presentation, we will look at how concept maps promote meaningful learning. Ausubel made a very important distinction between rote learning and meaningful learning. Meaningful learning requires three conditions. Firstly, the material to be learned must be conceptually clear and presented with language and examples relating to the learner's prior knowledge. Secondly, the learner must possess relevant prior knowledge. And thirdly, the learner must choose to learn meaningfully. Concept maps can help to identify concepts held prior to instruction on more specific concepts, and by assisting the sequencing of learning tasks through progressively more explicit knowledge that can be anchored into developing conceptual frameworks. The one condition over which the teacher has only indirect control is the motivation of students to choose to learn meaningfully. This indirect control is exercised by the teacher's choice of instructional strategy and evaluation strategy. Instructional strategies that emphasize relating new knowledge to the learner's existing knowledge foster meaningful learning. Evaluation strategies that encourage learners to relate ideas they possess with new ideas also encourage meaningful learning. Typical objective tests seldom require more than rote learning. In fact, the worst forms of objective tests, or short answers tests, require verbatim recall of statements, and this may be impeded by meaningful learning, where new knowledge is assimilated into existing frameworks, making it difficult to recall specific verbatim descriptions or definitions. This kind of problem was recognized years ago by Hoffman and is often termed the tyranny of testing. Concept maps can be used as a learning tool and also as an evaluation tool. They can be as effective as more time-consuming clinical interviews for identifying the relevant knowledge a learner possesses before or after instruction. The most critical parts of memory for incorporating knowledge into our long-term stores are the short-term and working memories. All information is organized and processed in the working memory by interaction with knowledge in long-term memory. The limiting feature is that working memory can process only a relatively small number of psychological units, namely between 5 and 9 at any one time. This means that relationships among 2 or 3 concepts are about the extent of our working memory's capacity. Concept mapping provides a template or scaffold to help us organize knowledge and structure it while it is being incorporated into long-term memory. Constructing concept maps enables the identification of knowledge gaps as well as errors in reasoning. Our brains work to organize knowledge in hierarchical frameworks, and learning approaches that facilitate this process enhance the capability of all learners. Iconic learning involves the storage of images of scenes we encounter, people we meet, photos, and a host of other images. These are also referred to as iconic memories. Humans have a remarkable ability to recall images, though they may soon forget the details in the images. CmapTools allows you to store images along with concepts. and thus promotes iconic memories. Sound files can also be embedded in concept maps. The human's ability to recall sounds is also good. This is referred to as archic memory. So-called learning style differences are to a large extent derivative from differences in the patterns of learning that students have employed, varying from high commitment to continuous rote learning to almost exclusive commitment to meaningful mode learning. It's not easy to help students who are habitually rote learners to move to meaningful learning. While concept maps can help, students also need to be taught something about brain mechanisms and knowledge organization in order to help them change.